All right. So the answer to number 1 was this right here. So you have some product rule there because there's 2 factors. So you have to do product rule on this. And the thing that most people get hung up on is when you take the derivative of arc sine of 5x, you're going to have the 5x down here squared. So you have to actually square it and become 25x squared, or leave it in parentheses as squared is fine. And then you also have to do the chain rule and take the derivative of the inside, which is going to pop that 5 out. And then the x from the product rule. Was there a question?
I was going to ask if, because I didn't square it, I just left it.
Yeah, that's okay. Yeah, that's fine. Okay, so that's the first one. The second one, what am I doing? All right, second one was pretty straightforward. You're just using power rule on each of these. The one that I noticed on my other class, quite a few of them got messed up on, was this minus pi. I had some people put minus 1/2 pi squared, where they were treating pi as if it was the variable x. But pi is just a constant, so the antiderivative of a constant in this case would be just negative pi x. And then plus c. And then the one on the back, let me move this up here. Okay, so first thing you would want to do here is split this into 3 separate fractions. So 2 over x squared, 4x over x squared, minus root over x squared, and then you would convert everything to rational exponents. Is that a question? That was like this, and I couldn't tell it.
What if the answer has like a -1? What if I brought the x down?
Drop it down? Oh, yeah, of course. Yeah, if you turn these into like drop them down and make them roots, that's all okay.
I forgot to put C.
If you forgot to put c, you're going to miss 1 point. Out of each one of these is worth 33 points, roughly.
Right.
So it's just, I have to remind you that there's something missing there, right? But I'm going to need you to start putting c in. I'll kind of be easy in the beginning, but like by the time we get to the first exam, like you need to be remembering the plus c, all right? Yeah, so you convert everything to rational exponents, and then you use power rule, except you cannot use power rule on this one, because that one's that special case where the n is -1, but that's just natural log. You have to have absolute value around the x. If you didn't do that, I'll probably take off 1 point. Okay? All right, so there's your first quiz. Some things to remember, just make sure you try and be here on time, because usually if I'm going to give a quiz like that, it's going to be right at the beginning of class. It's going to be timed, because we can't spend 20 minutes, 30 minutes on a quiz. Have your formula sheets with you, printed out, ready to go. All right? Any questions or anything?
Can you repeat what you said for the natural log?
When you take the antiderivative of 1 over x, it is natural log of the absolute value of x. And so this is an absolute value. I know it's kind of hard to see that it is, but that's an absolute value around that x. You just need to have that, and if it's missing, then it's not technically correct. But again, I'm not going to take off much right now for that. There we go. All right, so I'll try and get those graded most likely tomorrow and post those on Canvas. All right, I'd like to clarify something. I sent out this very confusing email today about the homework for 5.5. And if you bring up the notes on Canvas for 5.5 substitution, if you scroll to the bottom to get your homework assignment, you'll see there is no homework assignment down there. And that's because I just forgot to put it there. And those notes have been up, I've been using those for a few years, so I never really added anything to it. So what I did is this morning I emailed my 9 a.m. class after their class met to let them know, hey, here's the homework for 5.5. And some students in here interpreted that as that's the homework you were supposed to have for today, 5.5. So you were supposed to do 4.7 homework. This will be your homework for tonight, the 5.5 that I emailed you earlier. Is that clear? Okay. So we ended last class with this idea of substitution, right? We just barely started to talk about this. And the main thing I was trying to get you to see was that when we're trying to find antiderivatives and the power rule doesn't work and it's not something that we're familiar with, and we have to start to have these techniques to try and find antiderivatives. And the first sort of technique is this substitution rule. So what we're doing is we're going to look inside this integrand, and we're going to try and find something in there. And simultaneously, what we see in there, we have to also see its derivative somewhere in the integral. And there were two things about the derivative. The derivative should appear in the numerator. It shouldn't be trapped in the denominator. And it can also be off by a constant. And then once we have that, we're going to make the substitution u is equal to whatever we saw. And then from there, we'll do our stuff. Did I do an example? I think I did at least one example. So what I'm going to do today, I'm going to start with an example that I'm going to do. And then I'm going to randomly call on people for the next series of problems. I'm going to put a problem up. I'm going to pick someone out of here randomly. And that person only can guide the rest of us to what u is and go from there, right? Understand? So in other words, I'm going to put you on the spot and possibly make you feel uncomfortable. But I thought a lot about this today on my way to school, and I was thinking about, like, what if you were just like hanging out with some friends and y'all were trying to learn math? Like, you have to be willing to be a little bit humiliated if you don't know something. Like, we're here to learn, right? So I'm trying to really just kind of get into each of your heads to see like where you are. Some people are going to see the u right away and they're going to be able to do it, and some people will struggle with it. All right, we're all going to be at different places here, but there's no shame in the fact that we're here to learn, right? Hopefully, yes, thumbs up. If you don't get called on today, you are on the list, so you will be called on one of these days. I think most of you would hope to be called on today because the problems are just going to get harder as we progress. Once we get through everyone, we'll just cycle through again and we'll do it again. All right? I've never done it this way, so we'll see how this goes. Oops. All right. So I'll do the first one. And I'll give myself a real easy one. I guess I need some markers. Y'all feeling good? Yeah? Y'all ready? Cal 2's just about to start now. All right? Here we go. All right, this one looks interesting. Integral t squared t cubed plus 4 raised to the negative 1/2 dt. So the first thing I'll point out is that they're using the variable t, right, instead of x. So I look at this and I go, all right, well, can I use the power rule? I could if I could somehow separate this into separate terms. But this power on these two does not allow me to remove those parentheses, right? I cannot distribute this t squared through this because order of operations says I have to do this first. So there's no way to turn this into a bunch of t's to powers. Yeah? Agreed? Okay, so I start thinking substitution because that's kind of like the next thing on my Rolodex of things to do. Substitution. I start looking, do I see something and its derivative? So I look through here, and I know from Cal 1 that when I take derivatives of polynomials, powers come down. So if I look at this t cubed, I know the derivative of that is t squared. Well, 3t squared, right? And I have a t squared right here. I don't have 3t squared, but I have t squared. And that t squared is up in the numerator because there is no denominator here, right? And it's off by a constant, but like I said, that's okay. So things are looking good for me, right? I'm seeing something and I'm seeing its derivative. Yeah? Okay. But I actually see a little bit more. If I do the t cubed and the plus 4, If I take the derivative of that, it's the same thing, isn't it? It's still 3t squared. So what I'm going to do is I'm going to try and identify something. I'm going to grab as much as I possibly can without going overboard. And what I mean by overboard would be grabbing this entire thing. If I grab this whole thing, then what I'm saying is if I grab that whole thing, what's the derivative of this? It's not 3t squared. It's a bunch of other stuff too, right? The negative 1/2 would have to come down. It would be a very complicated derivative, and if I cover this up, I don't see it there, right? So the trick is to grab as much as you can without grabbing too much. All right? All right. U equals, so I'm making my substitution. I'm going to grab the t cubed plus the 4. And now at this step, I'm going to take the derivative on both sides with respect to t, because t is my variable here. So I'm going to go du dt. This is implicit differentiation, which is the same as differentiation, but this notation we like to use with implicit. So du dt, derivative of t cubed, we said was 3t squared, plus the derivative of 4, which is 0, so I don't need anything there. Now, the standard thing, you'll see me do this every single time. I will always get this little dt differential off both sides, so I'll multiply both sides by dt and have that. Pardon me?
That's all you need to
That's,
put it back in.
yeah, this right here should be enough, right? So if I come over here, that's multiplication, and I can rewrite this before I actually plug things in. I'm going to slide that t squared to the back. And the only reason I can slide that t squared to the back with the dt is because it's being multiplied, right? It's in the numerator and it's not trapped. Go ahead.
You put a 3 in front of the integral, right?
Well, the way I do it might be a little different if you've seen something like this before. The way I do it is a little different from that. What I do is I try and play a game where I match things up. All right, so what I do is I come over here and I say, all right, this t cubed plus 4, I will be able to replace that with u, right? Right there, that's going to become u. Agreed?
Oh, I skipped a step.
Now, the next thing I need to do is figure out how I can get rid of that t squared dt, right? I thought I had a red marker in here. Oh well, I have blue, that'll work. These colors don't come out too good on camera, but oh well. All right, so I'm going to try and figure out a way to get this t squared dt out of here and change it to something that has u's in it. But I see t squared dt here. There it is. So I'm going to try and isolate this in this equation. So I divide both sides by 3, or better yet, multiply both sides by 1/3. Right? And now that is this right here. So that piece right there is going to get replaced with what? 1/3 du. And that's multiplication between them, right? Do y'all see that? Okay, so now I will rewrite the integral. I'll keep that up there. This is going to become, I like to use arrows. Like, I like to say that this is equal to this, right? Those are equal because I'm using the same variable. But I like to use arrows whenever I switch my variable from t to u, all right? It is the same, but not quite because we've changed the actual letter. So let's write it. What is this? U to the -1/2. And then I have times 1/3 du, right? And then this is 1/3 integral u to the -1/2 du. So I pulled that 1/3 out. Am I allowed to do that? Yes, because remember we said when you're taking antiderivatives, if there's a constant attached to the function, the constant will come for the ride. So I may as well just bring it out here and just bring it with me the whole way. And now if you look at this, when you go back and look at what I talked about in the beginning or at the end of last class, I said this is just notation, right? This and this, right there are just telling you, look, this is a function that has u in it, right? Because that's the variable. And this is telling you, give me the antiderivative of this. Use the power rule. So you're going to do 1 over n plus 1 u to the n plus 1. Right? Okay, so let's see what that is. That should turn into, let's see, we still have the 1/3 out there. I'm going to go really detailed on this one. 1 over n plus 1 u to the n plus 1. And then what am I missing? Plus c. Okay, let me get this out of here. Now this is equal to 1/3 times what? 2. Right? This is 1 over a half. 1 over a half is 2, so this is 2. And then u to the half, right? Plus c. This is 2/3 u to the half plus c, which looks like an answer, but I got to go back to x, right? Because not x, sorry, t. I need to go back to t. My original variable was t. My answer needs to be in terms of t. So what was u? What was u? It was tq plus 4, right? That's what it was? So I'm going to rewrite this. This is equal to 2/3 parentheses tq plus 4 to the half plus c. And I can box this up as my answer. You could also convert this into a square root, right? Because to the 1/2 means square root. That's the antiderivative. How could we check? Take the derivative, right? And if I take the derivative of this, I better get t squared times the quantity tq plus 4 to the negative 1/2, which will happen. Do you all believe it will? Do I need to show it? In my previous class at 9 a.m., I had a skeptic in there. Didn't believe that it would work.
Showed up at 9:30.
No, it wasn't the 9:30 guy. No.
Was the 9:30 guy even here for it?
No, he wasn't there for that problem, yeah. All right, so y'all okay with that? You sure? Because I'm going to start calling on you all now. All right. Are y'all nervous or excited? Both. All right, so here's the way I'm going to do this. I have a list of 28 problems. So what I'm going to do is just before class, I went online, I looked up like calculus U substitution worksheets, and I just found this one on there, all right? The reason why I'm doing this and I'm not doing problems out of the book is because on the homework solution video, I did all 36 problems in the book. And I probably, if you were to look at my old lectures, I've probably done every single substitution problem, even in like the chapter reviews. So I'm kind of like exhausted with the book problems, and there's no sense in me doing them if they're already on video, right? So I'm just picking some other random problems here. So I'm going to call on you, then I'm going to let you pick a number 1 between 28. All right? So I'm going to give you some flexibility, but you don't know what you're getting. That's just so you know I'm not like I'm going to give you the hardest one, you know? I'm going to let you pick. All right, now as far as who I'm picking, that's going to be a little bit different. So how do I do this? I should have some sort of random generator, but you know what? I'll just go, I'm just going to...
Should have went back to elementary when they put their names on a stick and you get them out of the
Yeah, I have sticks in my office where I could do that and like shake them up and pull out your name. Okay, well let me ask this. Any volunteers? You want to go? Okay, let's get all the volunteers out first. You raise your hand first. So what's your name?
Daniel?
Daniel Ramirez.
Yeah.
Okay, I'm going to mark you as being here today. That'll be your attendance. Number between 1 and 28. You want to do 8? Okay, here it is. So please allow Daniel the opportunity to either fly or crash here, okay?